So hello, welcome to another day of example problems, this one for chapter 27. This is the last chapter on your next exam, with the next exam being 1 week from today on November 6th. Because dear God, November is over, tomorrow's Halloween. I should have done today in costume. And yeah, this chapter is all lenses and mirrors. I basically have all the equations up here kind of spread throughout, with this kernel being mirrors and this kernel being lenses. There's also the thick surfaces, the idea of instead of a thin lens just refracting through a thick piece of glass. I didn't put those equations up right here because there's none of those in this packet, though there might be some on the homework. In general, none of these are old exam questions because the old exam question we're just going to see on the exam. But a lot of these are kind of similar to the old exam questions. I'm probably going to do something with a lens or a mirror and going through these equations, which for the most part are pretty much the same between both. And I'm just going to jump right in. The first problem says a virtual image is formed 20 centimeters from a concave mirror. Okay, first things first. A concave mirror is something where you're looking at the inside of it. That's when the focal point and the radius of curvature are inside. A concave mirror, the focal length is positive half the radius. A convex mirror is the opposite. So a virtual image is formed 20 centimeters from a concave mirror having a radius of curvature 40 centimeters. So if its radius is 4 meters, that means its focal point is at 0.2 meters. What's the position of the object? Well, they say the virtual image is formed 20 centimeters away. That means P is also 0.2. However, it's virtual. For a mirror, and keep in mind mirrors, why'd you over there? Mirrors and lenses have opposite, but for a mirror, which I have over here, a image is positive when in front and negative when it's in back. But what this really means, if you remember from what I said, is that if something is in front of the mirror, that could be a real image. If it's a virtual image, that means it must be behind the mirror. That means this P, sorry, I said P here. That means the image is at -2. And sorry, I put P here, I should have put Q. P is the object, Q is the image. So I apologize for that mistake. And so I'm saying if the image is virtual, it's negative. And that's always true. That's true for lenses and mirrors. And a virtual is negative, a real is positive. So a virtual image at 0.2 and a focal length of also 0.2. So if I want to find position of the object, I'm looking for P. I'm just going to use my 1 over P plus 1 over Q equals 1 over F. I'll subtract 1 over Q from both sides to get 1 over P equals 1 over F minus 1 over Q, which will give me 1 divided by 0.2 minus -1 divided by 0.2, which is going to be double negative, so these are going to cancel. So I'm going to get 2 over 0.2. 2 divided by 0.2 over 0.2. 2 over 0.2 I can reduce the same as 1 over 0.1. And if 1 over P equals 1 over 0.1, that means P is 0.1 meter, or 10 centimeters. And that's going to be the distance of the object. Didn't even need a calculator. Part B is what's the magnification? Magnification is negative Q over P. So it's going to be negative 0.2 meters with a negative in front over 0.1 meter. And then you get an answer of 2. I can also say I know this image would be upright because the magnification is positive. Any questions? Okay.
Nope.
Let's slide this down. Or slide this up, I should say. Go to the next one. This one says, at an intersection of a hospital hallway, a convex spherical mirror is mounted high on a wall to help people avoid collision. So convex mirror means we're looking at the outside of the radius of curvature. That we're out here when where the shiny side is this way and the radius is in the middle. If I was to draw this the more traditional angle, aka I put this on the right side, that means my radius is behind it. That means my focal point is behind it. If my focal point is behind it, that means this is going to be, oops, sorry, undo this. That means it's going to be a negative focal length because the focal length is in back, assuming my image is in front. So the magnitude of the mirror's radius of curvature is 0.55 meters. That means the focal length, being r over 2, well, he'll be negative r over 2. Negative, once again, because it's behind. I can also just say it's a convex mirror. Convex will be negative. Concave will be positive. So negative, what did I just say, 0.55 meters? I don't have the other open on my other screen. So negative 0.55 meters over 2. That means my focal length is going to be 0.275 meters negative. Okay, so it says, locate the image of a patient located 10 meters from the mirror. They're pretty far away. That means P equals 10 meters. If I want to locate the image, 1 over P plus 1 over Q equals 1 over F. That means 1 over Q equals 1 over F minus 1 over P. And I'll say it is negative 1 over, just 1 over negative 0.275 meters minus 1 over 10 meters. When I do that, my double negatives add up. What did I do here? Oh, I see what I did. And when I do that, I get negative 3.736 inverse meters. But that's not Q, that's 1 over Q. So Q is 1 over negative 3.736, which will give me a value of negative 0.267 meters. I don't like that pen very much. Part B, is it upright or inverted? And part C is the magnification. Both of those are the same equation. Magnification is negative Q over P. So it'll be negative 0.267 meters over P, 10 meters, which doing that math will be positive 0.0267. Now I can look at this and I can say that it is upright because this is positive. I also know it's reduced if I ever ask for that because that's less than 1. And I didn't ask for this problem, but I could also say it's virtual since that was a negative answer right there. This is traditionally some of the easiest problems in this class, just because the equations are pretty simple. We good on mirrors?
Yep.
Let's do a lens. So now we're going to talk about lenses. So that's going to be this set of equations over here, which mostly is the same. Let me go back to my highlighter. So many emails. These and these equations are exactly the same. The only difference is finding the focal length. That for a mirror, it's just half the radius. For a lens, you need a complicated equation that whether or not it comes up into play on the exam is going to be of question anyways. So I can probably fit this in the bottom of this page. So I'm going to leave that information up there and just keep working. I'll switch colors to make it obvious. So a diverging lens has a focal length of magnitude 20 centimeters. Okay, so F is 0.2 meters. You really could work in centimeters with these. I just never do. But this is a diverging lens. A diverging lens is, well, you can just look at my little table here. I can say divergent, that's negative. If it's divergent, my focal length is negative 0.2 meters. And then it says locate the images for 3 cases. P equals 40, P equals 20, and P equals 10. And for each case, real, virtual, upright, inverted, magnification. Well, basically my equation will start the same. 1 over P plus 1 over Q equals 1 over F. Even though we're now talking about lenses, not mirrors, that doesn't change. So it'll still be 1 over Q equals 1 over F minus 1 over P. And for each one, I actually will need more space for this problem. I forgot I did 3 times. I can say I have a, what was it, P equals, my email popped up over my screen. P equals 40, 20, 10. So I can say PI is 0.4 meters. I'll just use all the colors. PII is 0.2 meters. And black will work. And PIII was what, 0.1 meter? I kept cutting in half. Yep. That for each one, I'll just plug into there. 1 over Q equals 1 over 0.2 meters minus 1 over 0.4 meters. Doing that, that's going to be 2 over 0.4 meters minus 1 over 0.4 meters equals 1 over 0.4 meters, which means Q equals 0.4. Assuming I just did my math right there. Oh, wait. Q is negative, wasn't it? Oh, F was negative. So I dropped this negative sign. 3. So negative 3 over 0.4. 0.4, inverting that, 0.4 over 3. That's going to be 0.4 over 3, 1.33, but it's off by 10. 0.133 meters, negative. That means this is a virtual image. I can then do the same for this guy and say 1 over negative 0.2 meters minus 1 over 0.2 meters, which is 2 over 0.2 meters. And therefore, inverting it, Q is going to be 0.1 meters negative. For my black one, 1 over negative 0.2 meters minus 1 over negative 0.1 meters, which is going to be 2 negative 3 over 0.2 meters. All right, 2/3. Oh, I looked at the wrong thing. Which is going to end up being negative 0.0667 meters. And I can get all 3 values of Q just by using that equation. Now, all of these are negative, so all of these are virtual. If I want to also know the magnification and whatnot of all of them, I'm just going to stick to colors. That in general, magnification equals negative Q over P. And so for my first one, where PI was 0.4 meters, the magnification is going to be negative 1.133. And because there's a negative here, we'll cancel that negative, so I'm just not going to include it, over 0.4 meters. That value is 0.33. It's going to be 1/3 the size. For my green one, it'll be negative 0.1 meters times negative 1 over 0.2 meters, which is going to be a half. And for my black one, 0.0667 meters over 0.1 meters. Once again, my negative cancels. And that's my magnifications. Now, every one of these is positive. So every one of these is upright. And I don't even need to that. I just know these are upright because that's positive. Now, all of these had negative Q, so they are all virtual. And that's the magnification for each. Any questions? What's the next one? The only way this gets positive. Oh, it's not positive. Oh no, sorry, I have another one before I get into. I was gonna say the only way this gets complicated is what I meant to say, but I have another one before that, which I worked in the middle of this page for no apparent reason, so now I'm gonna work above it. So let's go to the next one. The projection lens in a Soden slide projector, dear God, this is what I'm to use textbook problems, is a single thin lens. A slide 24 millimeters high. So that's its height. That's something we don't deal with often, but then its the actual height is 24 millimeters or 0.024 meters. It's projected so that the image, a real image, fills the screen 1.8 meters high. That's the height of the image. The slide to screen distance is 3 meters. Okay, let's start with that slide to screen image is. See, what I'm saying is I have something being an object that's being focused through a lens and is being displayed on a screen. Now, I put that upside down. That's mostly because I know it's going to be. I'll get into why I know that in a second. But if I say the slide to screen difference, that's not Q, that's not P. That's from my object to my image. So I'm going to say P plus Q is that distance I gave, 3 meters. Because I don't say the distance from, I say the object to the image. I don't say the object from the object to the lens or the lens to the object. So first bit, determine the focal length of the projector. Well, to determine the focal length, I need P or Q, and I only have P plus Q. But I also have this. And this says the magnification of something, or not this, but in general, is H prime over H, or negative Q over P. And you see, I can say that, well, first off, if I'm going to set these equal to each other, I say this is a real image. If this is a real image and this is true, that means if this is a real image, it means Q is positive and P is positive. Because real image, Q is positive. I think that's written, where is it? Nope, it's not written there. Oh yeah, there you go. Image location is positive when it's in back. A real image means Q is positive. If Q is positive and P is positive, M must be negative. So that's why I know this has to be inverted. It has to be inverted because it's a real image. And therefore P is positive and Q is positive. And so what I have to say is that this height H prime, if it gets inverted, I'm going to say it's upside down. It's upside down because, once again, it's a real image. If I said it was a virtual image, that means Q and P would have the same sign as each other. But Q and P must have the same sign since it's a real image. And so, okay, right here, H over H prime. H over H prime is going to be negative 1.8 meters over 0.024 meters. And negative 1.8 over negative 0.024 is negative 75. And I'm saying negative 75 also equals negative Q over P. So 75 equals Q over P. Or Q equals 75P. I'm going to take this and I'm going to shove it up there and say P plus Q equals 3 meters. That means 76p equals 3 meters, or p equals 3 meters over 76. And 3 divided by 76 is 0.0394 meters, which I think is the answer to B. B, how far from the slide should the lens of the projector be placed to form the image on the screen? There you go. There's my answer to that. But that's what I was looking for. I was actually trying to find the focal length at the time. For the focal length, though, I can just say 1 over P plus 1 over Q equals 1 over F. Now, I could solve for Q. If I plug in here, I could get Q directly. But I'm just going to say 1 over P plus 1 over 75P equals 1 over F. 1 over 75. I have a mistake. Oh, 76. Sorry. 76P. It was 76 right here, and then I.
You're right. It was 75. Then we added one more P.
Yep. I added, that was for this equation. Here it's 75. It's still 75 here. In the solutions, I plug in 76, and that is definitely a mistake. I'll need to fix that.
Caught your own error.
Yep. Because that 76, where that came from, was here. That was P. I'll just pull this over. Because it's right here. It's 75P plus P is 3 meters. That's what the 76 is. But then I use 76. So that is a mistake in my solutions. I will fix those when class ends today, which means I don't have the answer instantly. But I can find like thing, 75 over 75p plus 1 over 75p equals 1 over f. It's going to give me 76 over 75p equals 1 over f. I'm probably off the bottom. And therefore f equals 75p over 76. And you'd have to just do what that math is. Once again, my solution is going to be wrong. 75 times 0.0394 divided by 76, 0.0388. So that would be the focal length. I mean, this is me trying to make it tricky. And me trying to make it tricky is just you have to rearrange differently. These are pretty straightforward equations.
We could have, if we wanted to, though, right? Just taken the value that we got for P, that 0.0394, and then just put it into that equation up there on the middle-ish left.
You mean this one?
Yeah.
Yeah, exactly. I mean, so yeah, if I want to know what Q is just going to be 3 minus 0.0394. So Q is 2.9606. And I could have plugged that in there just as easily.
Gotcha.
That would have worked just fine. I decided to be fancy, and then because I decided to be fancy, messed it up. Sounds like me.
I like this better than forces.
Yeah, it's a lot easier than forces. Side note, I did write the exam for you guys, and I took it yesterday. This exam is shorter than the first exam. I made sure of it.
Well, thank God.
I mean, and that's the general idea for these problems. As I said, the only time they get complicated is maybe if I put 2 lenses, which is what this last one is. It has 2 lenses.
Put 2 lenses in space-time with friction and all this other stuff.
We will get to space-time. Oh, we will. That's 2 chapters from now.
Inverted inside a Mobius strip or something like crazy like that.
Like this last problem, I mean, if you want, I can do it, but I said I'm going to spend 25 minutes doing problems because theoretically you guys should be spending 25 minutes working on them yourself. That's the general idea. it's just going to be these 1 over P plus 1 over Q equals 1 over F. Last semester's exam was literally a question about a magnifying glass.
Like
Yeah.
the one on the homework.
Is it a magnifying glass in the homework? I don't remember. It was a pretty straightforward problem.
Yeah.
So I think I'm just going to stop there. If you have any questions, I would recommend for exam having either just remember what's positive, what's negative, what's virtual, what's real, or having, this table and these tables might not be a horrible idea, just accessible. Never mind the very simple equations. Okay? Other than that, have a good day.